Here's a quick video to show you how to extract the data you need for your transportation safety experiment in science class. You can see here, this is my Vernier Graphical Analysis application I've got open on my desktop. I've got my data set saved. I've set it to velocity along the y-axis and time along the x-axis. So I have a velocity time graph, which is nice because those are my two variables here. In the top right corner, if I click this icon and select Data Table, it will show me all of the data that I've collected for all of my trials in this demonstration. But there are hundreds of data points here, maybe even thousands, because I'm collecting 50 samples every second. I don't need that much data. I only need a few key data points. You can see here, the velocity is 0 because that's before I released the cart. Here's where I released it, and in this part of the graph, the cart was too close to the sensor, so it didn't get a clean reading. But from this point out to this point, you can see the cart has a nice smooth acceleration down the track where its velocity increases. The peak of this curve right here is the moment when the cart crashes into the barrier at the bottom of the track. And you can see that it decelerates to a velocity of 0 very, very quickly. And then here's where it rebounds or bounces back on the track after hitting the barrier. So to measure the impulse and the force, what we really need is we're focusing on the point of this curve from the moment that the cart hit the barrier, which is right here at the peak of the curve, and the moment when it crosses this x-axis at 0 meters per second. The way you can extract that from your data set is you're going to click right here, and it will show you on the screen what the velocity is, 1.624 meters per second, and it will also show you the time down here at the bottom, 2.24 seconds. So this number, this velocity, is your starting velocity, or the letter U in SUVATs, and this number down here is the time. That's the T in SUVATs. So this is your starting time, and that's your starting velocity. You'll also notice in the data table that it highlights that particular row for you. This is the second trial that I ran. That's why it's called data set 2. Here's my time, 2.24. Here's my velocity, 1.624. So you can see them right there. The other spot on this curve I'm most interested in is right here where it crosses the x-axis. If you'll notice, when I click on it, it doesn't go exactly to 0. This is the closest data point I have to where it went to 0, but that's fine because I still have an ending velocity of negative 0.432 meters per second, and I also have an ending time, 2.34 seconds. Again, that's also highlighted up here in your data set. So for trial 1, you're going to want to record the initial time, letter U, the initial time, time 1, and you're going to want to record the ending velocity or the final velocity, letter V, and the final time, TF or T2. And from those, you can calculate delta V, the change in velocity, and you can calculate delta T, the change in time. That allows you to calculate the acceleration from which you can determine the force. It allows you with the change in velocity, as long as you know the mass of the cart, it allows you to calculate the momentum of the cart, the change in the momentum, which is the impulse. So that's how you're going to get data points from that first trial. If you come over and you select the velocity for each of the trials that you ran at the same level of your independent variable, right? Here's where the cart is still, you've got all of this kind of irrelevant data in here, but right here in the middle on all of these lines, you've got a very consistent acceleration down the track, and that's a clear indicator that you've got some relatively reliable data. Now, each one of these lines you want to treat the same way I did with the first line, where you're going to identify the peak of the line. Right? In the red case, it's 1.771 meters per second, and you can see that over here in data set 5. Right? You record that information along with the time there. And so you can then calculate the acceleration and the change in velocity for every single trial. That goes into your processed data. From there, we'll work on making graphs. But that's what you need to do to be able to get your data out of the Vernier Graphic Analysis software.